Somewhere in Istanbul, right now, a man is starting his car. It is a 2002 BMW 530D. The paint is oxidized down to the primer on the bonnet. The front bumper has been replaced twice, with two different bumpers. The interior smells of old leather, dried coffee, and 22 years of strangers sitting in the back seat. The odometer reads 547,000 kilometers. He turns the key. The engine starts. It starts the same way it started yesterday, and the day before that, and every single day for the past decade that this man has owned it. No hesitation, no smoke, no fault codes, no warning lights. Just a straight six diesel coming to life with the calm, unhurried confidence of something that has absolutely nothing to prove. He drives to work. Now picture something else. A brand new crossover, somewhere in the English Midlands. 3 years old, 26,000 miles. Still under the extended warranty the dealer sold with such enthusiasm. It is on the back of a flatbed right now, being recovered from a motorway hard shoulder, because the turbo has failed and the engine management system has gone into a kind of electronic panic that no one, not the recovery driver, not the dealer, not the manufacturer's helpline, can quite explain. The owner is on the phone to his finance company. He has 2 years and 8 months left on his contract. Both of these vehicles, when they left their respective factories, cost roughly the same amount of money. One of them was built to be replaced. The other was built to last. And it is doing exactly that, 500,000 kilometers later, in a city on the Bosphorus, driven by a man who has never once opened the bonnet with fear in his eyes. The engine in that BMW is called the M57. And the reason it is still alive, the reason it will almost certainly outlive the car around it, and the car that comes after, and possibly the car after that, is not luck. It is not coincidence. It is a set of deliberate engineering decisions made by a specific group of people at a specific moment in BMW's history. Decisions that cost money. Decisions that made the accountants uncomfortable. Decisions that were, in the context of everything that has happened to the automotive industry since, never repeated. This is the story of those decisions, and of what happens when engineers are allowed, just once, to build something properly. To understand what the M57 actually is, you have to go back to 1998, and you have to understand what kind of pressure BMW was under at that moment. The Japanese had spent the previous decade building cars that simply did not break. Toyota had made reliability boring, which is the highest possible compliment you can give a manufacturer. Honda had done the same. German prestige was real, but so was the anxiety that came with it. The anxiety of a reputation built on engineering excellence, now being tested against companies that had made excellence systematic rather than aspirational. Inside BMW's engineering departments, the accountants were winning. Not obviously, not with announcements, but in the small, cumulative way that financial pressure always works. The meetings where material specifications get questioned. The sign-off processes where cost targets start to override performance targets. The slow drift toward asking not what is the best way to build this, but what is the cheapest way to build this that still passes the test. Against this backdrop, a team of BMW engineers was given a brief to build a new straight-six diesel. A diesel that could go into the 5 Series. A diesel that would carry the BMW badge and be expected to behave like one. A diesel that could, finally, make the case that oil-burning engines were not the compromise choice. Not the thing you bought when you couldn't afford the petrol version, but a legitimate, refined, capable alternative. The team that built what became the M57 made a decision early in the development process. They were going to build it right. Not right for the cost target, not right for the production schedule. Right in the way that engineers mean when they use the word among themselves, meaning built to last, built with material integrity, built to tolerances that assume the engine will still be working when everything else around it has given up. In 1998, when the M57 first appeared in the E39-5 series, the automotive press called it a revelation, a new benchmark for diesel refinement, a demonstration that BMW had transformed what a diesel engine could be. They were measuring it in weeks and months. History would measure it in decades. Go inside the M57 and you find almost immediately a decision that tells you everything about the philosophy behind it. The block is cast iron. By 1998, cast iron was already becoming unfashionable in engine design. Aluminium was lighter. It was easier to cast in complex shapes. It shed heat faster and allowed smaller, lighter engine bays. Aluminium was the future, and BMW's own accountants reportedly pushed hard for it. They were overruled. The M57 got cast iron, and it got it for a reason that had nothing to do with fashion and everything to do with physics. Cast iron expands and contracts more predictably under heat than aluminium. In practical terms, this means that the tolerances between moving parts, the tiny critical gaps between pistons and cylinder walls, between bearing journals and crankshaft, remain stable over a far wider range of operating temperatures. A cast iron engine wears slowly and evenly for hundreds of thousands of kilometers. An aluminium engine, under the same conditions, often does not. The weight penalty is real. The longevity advantage is more real. The crankshaft is forged steel, not cast, forged. This distinction matters more than it sounds. Casting metal involves pouring molten material into a mold and allowing it to solidify. The result is strong, but it contains microscopic voids and discontinuities in the grain structure of the metal. Tiny imperfections that, under repeated stress, eventually become cracks. Forging takes solid metal and compresses it under enormous pressure. The grain structure aligns. The voids disappear. The result is a component that can absorb the violent, repetitive hammer blows of diesel combustion for 500,000 kilometers without developing fatigue failure. Forging is slower. It is more expensive. BMW did it anyway. The connecting rods are also forged. Same reasoning, same result. A forged connecting rod under high boost pressure bends slightly before it fails, which is a warning, a signal, something a mechanic can catch in time. A cast rod simply snaps, and when a connecting rod snaps inside a running engine, the consequences are described in the trade as catastrophic, which is a clinical word for an engine that now looks like a grenade went off inside it. The turbocharger is a Garrett unit, tuned specifically for low-end torque delivery rather than peak power. BMW did not want a diesel that needed to be flogged to produce results. They wanted torque available from almost idle, the kind of shove that makes a large, heavy saloon car feel effortless in traffic, on motorways, on long alpine climbs. The original M57 produced 390 Newton-meters. In its final evolution, the M57 TUE2, that figure exceeded 500 Newton-meters in standard form. These are numbers that, in 1998, felt almost absurd for a passenger car diesel. The fuel system ran common rail injection, high-pressure delivery, precise timing, clean combustion. This was not just about performance. A fuel system that burns cleanly leaves fewer deposits in the combustion chamber, fewer deposits in the injectors, fewer deposits in the oil. Fewer deposits means the engine stays cleaner internally for longer. An engine that stays clean internally wears at a rate that is, in practical terms, almost unmeasurable. Add the oil cooler, the carefully engineered lubrication circuit, the belt-driven injection pump with its long service intervals, and you have an engine that was, by any reasonable commercial calculation, wildly, almost recklessly overbuilt for its intended purpose. No taxi driver needs forged connecting rods. No company car fleet manager asked for a cast iron block. BMW built them anyway. And the consequence of that decision is still running. In 1994, BMW made what would eventually be recognized as one of the worst corporate decisions in modern automotive history. They bought the Rover Group. The idea at the time was not entirely unreasonable. BMW wanted volume. They wanted a presence in market segments. Small cars, off-roaders, premium saloons below the 3 Series, that they couldn't fill with their own products without diluting the badge. Rover gave them that volume. It also gave them Land Rover, which gave them Range Rover, which gave them access to the fastest-growing premium segment in the world. What BMW did not fully account for was the state of what they were buying. Rover's product quality was inconsistent at best and embarrassing at worst. The factories were inefficient. The model ranges were aging. The engineering talent was being slowly hemorrhaged to competitors. And the cultural gap between BMW's methodical, process-driven German engineering culture and the more improvised, underfunded British industrial tradition was, in practice, almost unbridgeable. The losses were catastrophic. By the late 1990s, BMW was bleeding hundreds of millions of pounds a year into Rover. The German press took to calling it Das englische Patient, the English patient. The nickname was not affectionate. But inside this disaster, something interesting happened. Land Rover needed a diesel engine for the new Range Rover, the L322, which was due to launch in 2002. The engine they had been using was adequate for an era when adequate was acceptable. The new Range Rover was supposed to be a genuine luxury vehicle, competing with the best of what Mercedes and Lexus and Bentley were producing in the SUV space. It could not go to market with an adequate engine. So Land Rover went to BMW, and BMW gave them the M57. Land Rover called it the TD6. They put it in the L322, and for a time it was the finest thing about that vehicle. Smooth under load, quiet at motorway speeds, capable of pulling a laden horse trailer up a Welsh mountain pass without drama or complaint. Range Rover buyers who specified the diesel came away impressed in a way that Land Rover's own engineering had not been able to achieve. The engine felt car-like, which was the highest compliment possible, and it was the M57 doing precisely what the M57 was built to do. The rest of the vehicle was a different matter entirely. The air suspension failed. The electronics failed at a rate that Land Rover's own engineers found difficult to explain with straight faces. The ZF gearbox suffered. Interior components delaminated. Coolant leaked from locations that required partial dismantling to reach. Owners of the L322 diesel in those early years developed a darkly specific kind of humour, the kind that emerges when you love something unreservedly while being fully aware that it is slowly destroying your bank account. And yet the engine survived all of it. When L322s went to breakers' yards, and they went in numbers, it was almost never the engine that had failed. Mechanics would pull the M57, clean it, and reinstall it in the next car along. Sometimes the next Range Rover, sometimes a Defender conversion, sometimes a boat. sometimes in parts of Eastern Europe and the Middle East, into vehicles that BMW's marketing department would rather not know about. The engine simply carried on running, indifferent to the chaos that surrounded it. BMW sold the Rover Group in 2000, keeping Mini and walking away from everything else. Land Rover eventually passed to Ford, then to Tata. The TD6 continued in production, because what else were they going to use? Until Land Rover could develop something of their own. It was a long time before anything they built came close to matching what they had briefly held in their hands, and then given back. Here is what nobody mentions when they describe the M57 as a reliable workhorse. In standard form, the M57 produces between 184 and 235 horsepower, depending on variant and year. These are not exciting numbers. They are the numbers of an engine that was designed to move a large, heavy car with authority and composure. An engine that does not need to announce itself because it already knows it has exactly as much power as it needs. What the engineers knew, and what BMW's tuning community was about to discover, was that the difference between what the M57 was asked to produce and what the M57 was actually capable of producing was enormous. The first hint came from the ECU maps. The engine management software in the standard M57 runs conservative fuel and boost targets. Conservative not because the engine requires it, but because BMW's emissions and warranty calculations require it. An ECU remap on a standard, unmodified M57, nothing changed physically, no parts replaced, nothing touched except the software, typically moves output to between 250 and 270 horsepower. Torque climbs past 500 Newton meters. The bottom end, the cast iron block and the forged crank and the forged rods, does not complain. It was built for this. It was built, structurally, for considerably more than this. Stage 2 involves an uprated intercooler, a performance exhaust, and a revised intake. Power reaches between 340 and 380 horsepower. Torque approaches 600 Newton meters. At this point, you have crossed a threshold. A BMW 3 Series or 5 Series running a Stage 2 M57 is no longer a comfortable, refined diesel express. It is a weapon. It will run down hot hatches. It will embarrass sports saloons. It will do things on a motorway slip road that cause passengers to check that their seatbelts are fastened. Stage 3 is when it becomes necessary to pause and verify the numbers are correct, because they do not immediately sound credible. A larger turbocharger, uprated injectors, a fuel pump capable of supplying the volume the new turbo demands. Standard internal components, the forged crank, the forged rods, the cast iron block were retained because they do not need to be changed. Output 420 to 460 horsepower. Torque 800 Newton meters. For context, a Lamborghini Huracan LP610-4 produces approximately 600 Newton meters of torque. A Ferrari 488 GTB produces 560. The McLaren 570S produces 600. These are mid-engined supercars with racing-derived powertrains, built specifically to produce maximum output, sold for £200,000 and upward. The M57, in a stripped E46 estate or a lightweight E34, on a Stage 3 build, produces 800, and it does so without the engine being under meaningful stress. It does so within the tolerances that the BMW engineers specified in 1997 and 1998. It does so using materials they chose, with a structure they designed, at loads they had already accounted for. The accountants wanted to make it cheaper. The engineers said no. This 800 Newton meters from a 25-year-old diesel that cost £40,000 new is what happened as a result. No honest account of this engine leaves this part out. The M57 has two specific failure points. They are not random failures. They are not mysterious. They are predictable. They are well documented. They are cheap to address, and they have destroyed engines that their owners believed to be indestructible, because the owners didn't know about them, or knew and didn't act. The first is the swirl flap system. Swirl flaps are small butterfly valves in the inlet manifold, designed to control airflow characteristics at low loads and cold starts. The theory is sound. The execution on the M57 is not. Each flap is mounted on a shaft retained by a small nut. Over time, particularly on high-mileage engines or engines that have been run at sustained high loads, these nuts work loose. When a nut detaches, the shaft drops into the inlet tract and is pulled directly into the engine. The damage is catastrophic and total. BMW were aware of this issue. They issued revised parts. They did not, at the time, communicate the urgency to owners with the clarity the situation warranted. The fix is a swirl flap delete kit. The flaps are removed and the ports blanked. There is a marginal penalty in cold start emissions and idle refinement. In every other condition, every condition in which anyone drives a car, the difference is functionally undetectable. Any M57 owner who has not done this, or who cannot confirm it has been done by a previous owner with receipts, should stop reading this and make an appointment with a mechanic before tomorrow. The second vulnerability is the cooling system. The M57's thermostat housing and several of the coolant pipes are plastic. BMW used plastic cooling components across most of their vehicles of this era: E46, E39, E53, E38, and in every case the plastic degrades over time. It becomes brittle, it cracks, it fails. A failed thermostat does not necessarily announce itself with steam and a temperature gauge in the red. It can fail in a way that allows the engine to run cold, which increases wear, or marginally hot, which over extended periods stresses the head gasket. A comprehensive cooling system refresh, new thermostat, new housing, new hoses, new water pump, fresh coolant, costs under £300 in parts. It is standard preventive maintenance on any M57 over 150,000 kilometres. The consequences of neglecting it can cost 5 times that. These two things are not reasons to avoid the M57. They are the things you need to know before you own one. An engine with 2 known, specific, affordable failure points is not a problematic engine. It is an honest one. Knowing what is coming is always better than being surprised. The M57, in almost every other respect, is entirely on your side. So why don't they build them like this anymore? The answer is not complicated. It is just not comfortable to say out loud. The modern automotive industry is not primarily a manufacturing industry. It is a financial services industry that manufactures cars as a side effect. The product is not the vehicle. The product is the contract, the finance agreement, the monthly payment, the maintenance plan, the extended warranty, the replacement cycle. A car that lasts 500,000 kilometers is, from this perspective, not a triumph of engineering. It is a failure of commercial planning. It represents a customer who will not need a new car for 20 years, which is 20 years of lost revenue. This is not speculation. It is not cynicism dressed up as analysis. The planned obsolescence of modern consumer vehicles is documented, discussed at industry conferences, modeled in financial projections, and built into engineering briefs. Engineers know it. The people who hire engineers know it. The brief today is not "build this to last." The brief is "build this to last long enough." Long enough that the warranty expires before the failures begin. Long enough that the customer associates the breakdown with bad luck rather than design intent. Long enough to be defensible. The M57 came from a different moment. A moment before, the balance of power inside BMW's engineering culture had fully shifted. When the people who decided how to build an engine still had the authority to prioritize longevity over cost, they still believed that the point of an engineering department was to produce things that worked. Not for 3 years, not for 5, but for as long as materials and physics allowed. That moment passed. It passed at BMW around the time of the E90, the 3 Series that arrived in 2005. When the N-Series engines began to show the cost optimization that the M57 had been built without. It passed at most manufacturers around the same time. The financial logic was simply too powerful, and the engineering culture too slowly eroded for it to have gone any other way. What remains are the engines that were built before it passed. There are M57 units alive today that are older than the careers of engineers currently working in Munich. They are in taxis in Istanbul and Bucharest. They are in resto-mod Land Rovers in Scotland. They are in diesel drag builds in Poland and the Czech Republic. They are in boats, generators, and agricultural conversions. They are in E39s and E46s and E38s and E53s that long ago ceased to have any conventional resale value and have instead acquired something rarer: the value of a thing that simply will not stop working. When these cars eventually go to a breaker's yard, the mechanics pull the engine first. Not because it failed, because it didn't. Because even at the end, the M57 is worth more than the vehicle around it. It will be cleaned, tested, and reinstalled somewhere else, where it will continue doing the only thing it was ever designed to do: work. Without complaint, without failure, without end. The M57. The last engine BMW built when they still believed that building something properly was reason enough.